Hello students, today we begin with the chapter of gravitation. We will be covering this chapter in two lectures, and in today's lecture let us start with Newton's law of gravitation. Consider you have 2 point masses. Say you have a mass m1 and you have another mass m2. We are saying these two masses m1 and m2, they are point masses. m1 and m2 are point masses. What is the meaning of point masses? Meaning of point masses is that the size of the mass is very small compared to the interactive distance between them. Let us suppose the interactive distance between them is capital R. That means the separation between these two masses, that is capital R. And with respect to this capital R, the dimension of these masses, that is very small, and then you happen to call them point masses. Now the Newton's law says that there is an attractive force between them, and the force acting between this mass and this mass is given by F is equal to minus G m1 m2 upon R square. This is essentially the Newton's law of gravitation, which is involving so many factors, and one by one let us try to understand what is the meaning involved into all these terms. First of all, you see this F means force between these two masses. This negative sign means that the force between them is attractive. That is a kind of convention we are following. And remember that gravitational force is always attractive in nature, always attractive, it is not repulsive. For example, you might have studied little bit that in case of charges, the force can be attractive as well as repulsive. But so long as this gravitational force is concerned, they are always attractive. That is why this minus sign is there. This m1 and m2 which you see, they are point masses as you have shown already, and R is the separation between them. Maybe from center to center, separation is R, and there is a capital G here, which is called, capital G is called universal gravitational constant. This is called universal gravitational constant. What is the meaning of this universal? Universal means whatever may be the two masses, maybe you and me, maybe moon and earth, maybe sun and the earth, everywhere the value of this capital G will remain same. It has been experimentally obtained that the value of capital G is around 6.67 into 10 to the power minus 11 Newton meter square per kilogram square. You understand? The meaning of universal is that whatever may be the two bodies, this value of universal gravitational constant will not change, it will remain constant. Now, there are certain points involved in this particular equation. First of all, remember that this force is independent of the medium in which the objects have been kept. I will write it here. F is independent of the medium. Force F is independent of the medium, means whether these two masses are kept in air, kept in vacuum, kept in some liquid medium, the value of force will remain same so long as the masses are same and so long as the separation between them is same. This is a very important concept you have to remember. This does not happen in case of charges. Those things we will study in class 12. There we will find that in case charges are kept in some other medium, the force changes. But so long as the gravitational force of attraction is concerned, even if the masses are kept in some other medium, the force remains same. This is the first thing you have to understand. Second thing, remember that only spherical masses can be treated as point masses. Only spherical masses can be treated as point masses. Now, what is the meaning of this? Assume that the masses here, which you say M1 and M2, they are not point masses, rather they have got some definite shape. Let us suppose I consider that the masses are of larger size. Masses are of larger size. Then you see, if they are spherical in shape, then it has been proved that the entire mass can be assumed to be concentrated at their center, and center to center distance will be capital R. In case the bodies are of some other shape, maybe a ring or disc, then you cannot make this kind of assumption. However, so long as center of mass is concerned, you assume that the masses are concentrated at the center. But so long as this law is concerned, remember that it's only the spherical masses whose mass can be assumed to be concentrated at the center and not other bodies. This is a very important thing you have to remember. And the third thing which you should remember, is that G is universal constant. G is universal constant, that is, whatever may be the bodies, this value will remain same. These are the 3 points you should remember so long as this equation is concerned. Now, along with this law, there is another independent law which you call the principle of superposition. Let us see what is the meaning of this principle of superposition. Let us talk about the principle of superposition. Remember that this is a kind of mathematical concept which you will be coming across in several chapters. Right now in chapter of gravitation, later on in class 11, in the chapter of waves you will be coming across, and in 12th you will be coming across in electrostatics. What essentially this principle means is that, imagine you have a mass capital M here, I am taking it as a point mass, which is surrounded by several other masses. Say you have M1, M2 surrounding it, maybe there are total n masses, I am calling it Mn, maybe M3, M4, all those masses are present here. Then this principle says that M1 will be applying an attractive force on this capital M, say in this direction, and the value is like this. M2 will also be applying a force, maybe the force is being represented like this. The nth mass will also be applying a force on this, I am calling it Fn. The superposition principle says that the total force on M total force on capital M, if you are denoting it by F vector, it will be equal to the vector sum of all the individual forces acting on it. Say the M1 is applying a force F1, I am denoting it by vector. This is essentially the vector addition. M2 is applying a force, say F2, so F2 vector has been written. And this is the meaning of principle of superposition. For example, Newton's law of gravitation was given only for two masses, but in case you have a situation in which several masses are present, then how will you calculate the force? Then that force will be calculated with the help of principle of superposition. Or in other sense, you can say that Newton's law of gravitation and the principle of superposition, both of them combined becomes the complete law to deal with all the objects you will be coming across. Understand? This becomes complete only when you are adding these two laws. Newton's law of gravitation along with the principle of superposition is powerful enough to deal with all the objects. Maybe this particular principle of superposition at times is not mentioned in this form. Rather, the other way of looking at this particular concept is that the force applied by one mass is independent. In the sense, whether M2 is present or not, the mass M1 will be continuing applying a force F1. On the similar sense, you can say whether M1, all these masses are present or not, this M2 will be applying a force F2 independent of the presence of other masses. So I should write it here. In other words, you can say gravitational force applied by one mass on capital M is independent of the presence of other masses. One mass means M1, other masses means M2, M3, M4, Mn, or maybe if you are considering M2 as one mass, then other masses are M1, M3, M4 and so on. This is another way of expressing this principle of superposition. One way of expressing is that the net force acting on M is the vector sum of individual forces, and in other words you can say that the force applied by one mass is independent of the presence of other masses. These are the two common ways in which you can express the principle of superposition. Now when we get into the applied part of this Newton's law of gravitation and principle of superposition, let us talk about a very important concept which you call acceleration due to gravity.